Move on to the next one. So we have a 50-inch piece of wire is to be cut into two parts, one part being 9 times the length of the other. Find the length of each part. Okay, so we don't have a general equation for this, so we need to write down some variables here. We want to find the length of each of what? Well, we're going to cut the wire into two parts. Okay, so one is going to be the small one, one is going to be the short one. Doesn't really matter. So I'll just put first part, we'll make that X, and then I'll put the second part, and we'll say that one's going to be Y. And we know that if we add X plus Y, we have to get back the original 50 inches of wire. Now, we do know that one part being 9 times the length of the other. So let's say we went over to Y and we say, well, this is actually 9 times the length of the other, or 9 times X. Okay, well, we can just plug that in here. We say X plus, but instead of Y, I can instead write 9X. Okay, so 1X plus 9X is 10X, and 10X is equal to 50. How do we undo the multiplication of X by 10? Well, we divide by 10, and whatever we do to one side, we do to the other, giving me X is equal to 5. So we know the first one must be 5. And 9 times 5 for the second one, 9 times 5 is 45. So we know the first piece is 5, and the second piece is 45. And if we add 5 to 45, we get a 50, which is the original one, so it works out. So a lab technician wishes to mix a 10% salt solution with a 2% salt solution to obtain 9 liters of an 8% salt solution. How many liters of each should be added? Okay, so first of all, we don't have general equations for a 10%. They say how many liters of each should be added. So we're going to be adding some unknown number of liters of 10% solution to some unknown liters of 2% solution. So we have a 10% solution, I'll just name that X, and we have a 2% solution, unknown amount, which we're going to name Y. We do know that if we add the 10% solution to the 2% solution, we should end up with a total of 9 liters. Now, if I wanted to put this in terms of pure solution, salt solution, I would say, well, 10% of X plus 2% of Y must give me 8% of the final solution, which is 9 liters. Now, let's say I want to get rid of all these percents. Well, I could rewrite them as decimals, which is 0.1, X plus 0.02Y equals 0.08 times 9. And then we can multiply everything by 100 to get rid of those two decimal places. Move them over 2, move them over 2, move them over 2, which gives me 10x plus 2y equals 8 times 9. Now, if it occurred to you I could have just gotten rid of the percentages and gotten the same thing, you're absolutely correct, because in this case, every one of the terms on both sides of the equation began with a percent. If that's not true, you can't just get rid of the percent. You have to multiply by 100. And we'll probably do an example of that later on. So now we have 10x plus 2y equals 8 times 7, which is 72. Now, okay, so now we have two equations. We have 10x plus 2y is equal to 72, and we have x plus y is equal to 9. So x plus y equals 9. Now let's say we wanted to cancel some one of these out. Say we wanted to get rid of our x's. Well, the least common multiple between a 10x and an x is 10. The least common multiple between a 2y and a 1y is a 2. So it makes more sense to get rid of the 2. Smaller LCM. So to turn this 1 into a 2, I have to multiply by 2. And since both the 2 and the 1 are positive to begin with, I need to multiply by a negative 2. So we end up with 10x plus 2y equals 72. Negative 2 times x is negative 2x. Negative 2 times positive y is negative 2y. Negative 2 times positive 9 is negative 18. 10x plus negative 2 is 8x. Positive 2y plus negative 2y. 72 plus negative 18 is going to be a positive 54. Now we want to undo the multiplication of x by 8 by dividing by 8. What if we do to one side, we do to the other? That leaves me x is equal to 6.75. Now, we can go back to one of our original equations, except plug in 6.75 for x and then solve for y. So x plus y is equal to 9 is now 6.75 plus y is equal to 9. So 6 minus 6.75 minus 6.75, cancel, cancel. We end up with y is equal to 2.25. All right, now we can actually go back and check our work if you want to. So we go back to our other equation, which is 0.1 times x, x being 6.75, plus 0.02 times y, y being 2.25, and theoretically that should be equal to 0.08 times 9. And that one turns out to be true, so we can move on to the next one. So a 20-ton mixture of crushed rock is needed in a construction job. It will cost $580. If the mixture is composed of rock costing $20 per ton and $50 per ton, how many tons of each should be added? So we want a 20-ton mixture of crushed rocks. So there's going to be some that's $20 per ton and some that's going to be $50 per ton. Now, we know the total cost is going to be 20 times, for instance, there's no equation, so we need to define our variable. So let's say we say the $20 one is going to be our x, and we say the $50 per ton one is going to be our y. Okay, and we know that if the total amount that we end up with is 20 tons. So x plus y is equal to 20. Now the way we calculate the cost of this is $20, or $20 per ton of one plus $50 per ton of the other, and we want it to cost about $580. Okay, so we have two equations. Now, first of all, this other equation I'm going to divide by 10 just because you can divide this entire time. That'll make things a little easier on you. Divide everything by 10 means you just get rid of this last zero on every one of those. So you end up with 2x plus 5y equals 58 instead. So we want to find the value of this. Now, you have 2x plus 5y equals 58. Okay. Now, let's say you want to get rid of the x's. The least common multiple of a 1 and a 2 is a 2. Least common multiple of a y, of a 1y and a 5y is a 5. So x's will be easier to get rid of. So I'm going to multiply this by a negative 2. Right? They both are positive, so I have to flip the sign of the first one. So negative 2 times x is negative 2x. And negative 2 times y is negative 2y. Negative 2 times 20 is negative 40. And 2x plus negative 2x cancels out. 5y minus 2y is 3y. 58 minus 40 is 18. We undo the multiplication of y by 3 by dividing by 3. Cancel, cancel. We end up with y is equal to 6. Next, we want to find the amount of x. We know that x plus y equals 20. Therefore, x plus 6 equals 20. So minus 6, cancel, cancel. We end up with x is equal to 14. So we have 14 tons of the $20 one and 6 tons of the $50 one. Now we go back and check that if we wanted to. So it'd be 280 plus 300 equals 580, which checks out.